Hi everyone, I hope you're okay. This is the fifth video, guys, whereby I'm answering the past examination question papers with regards to momentum and impulse only. Please note that, guys, the other videos are on the playlist. You'll find the playlist if you click the link on the description below. The second link will direct you to the playlist whereby I'm just answering questions. You can answer the questions with me. And then the first link is for those who still want to learn momentum from scratch. So yeah, just stay tuned, guys. And before we start, guys, please don't forget to share this video to your peers. Don't forget to like, comment. Most importantly, guys, please help us grow the channel by just subscribing. Okay, question 5. The diagram below shows two skateboards, A and B, initially at rest. Okay, with the cat standing on skateboard A. The skateboards are in a straight line, one in front of the other and in a short distance apart. The surface is flat and frictionless. Okay, the surface is flat, frictionless, and horizontal. First question, they want us to state the principle of conservation of linear momentum in words. It simply says that in an isolated system, the total linear momentum is conserved in both magnitude and direction. Okay, we are told that each skateboard has a mass of 3.5 kg. The cat has a mass of 2.6 kilograms. Okay, and the cat jumps from skateboard A with a horizontal velocity of 3 meters per second and lands on a skateboard with on skateboard B with the same velocity of 3 meters per second. Okay, they've illustrated the movement of the cat here. First question, they want us to calculate the velocity of skateboard A after the cat jumped. The velocity of skateboard A after the cat jumped. Simply say since guys we have an isolated system, we can simply say that for every collision that happens, momentum is conserved. All right, together. So it will be the mass of skateboard A multiplied by the velocity of skateboard A initially plus the mass of the cat, but initially they were combined. Let me do this. Initially they were together. It was mass of skateboard A plus mass of the cat multiplied by the initial velocity, and then finally mass of skateboard A and the velocity final plus mass of the cat, velocity of the cat finally. Initially, guys, initially these things were at rest out together. So the velocity of both the cat and the skateboard and the skateboard initially was 0 meters per second. If I multiply everything by 0 on the left hand side, I'll simply get a 0 out together, and then I'll say 3.5 multiplied by velocity of the skateboard plus 2.6 multiplied by the velocity of the cat, which is just 3. Yeah, and then therefore you obviously perform a mathematical gymnastics. The velocity of the skateboards after collision has to be negative. You'll take this thing to the left hand side, it will change the sign obviously. 2.6 times 3 divide by 3.5, you'll simply get a negative 2.22 meters per second altogether, which simply shows that the skateboard will move in an opposite direction with the cat. So the velocity of skateboard A after collision is just 2.22 2.223. What did I write there? It's 2.228. That's 2.23, ne? It's 2.23 meters per second to the left. To the left. Okay, immediately after the cat has landed, the cat and the skateboard move horizontally at the speed of 1.8 meters per second. Calculate the magnitude of impulse on skateboard B as a result of the cat's landing. Okay, but for the impulse, ne? Remember that impulse, guys, by definition, impulse impulse is the product of F net and the change in time, ne? But we know that F net and change in time are both equals to change in momentum. Are we together? So MVF minus MVI. When I find the impulse of skateboard B, right? The mass of the skateboard is just 3.5. The velocity after collision is just 1.28. Initially, before collision, the skateboard was at rest. It started moving after collision when the cat landed on it. So it's just 3.5 multiplied by 1.28 minus 0. You'll simplify into 4.48. Since we're dealing with impulse, that's Newton's seconds. I'm SI units are corner, or if you wanted to, you could have written kg meters per second. Since they only wanted magnitude, direction doesn't matter, ne? But if this weight was not there, we're just going to say to the right. So the magnitude of impulse, let me write it in red, it's just 4.48 newtons second. That's how, guys, you could have answered that question over there.